Alrighty. I'm James Bunton, and this is my stat project on resistance to aero penetration of fabrics. Now, for this experiment, I used three types of fabric: cotton, felt, and linen. Cotton is just cheap cotton broadcloth. Felt, it's by far the thickest of all of the three fabrics, and it's different because it's actually made from, well, felted animal fibers. Excuse me. Linen's the thinnest out of all three of them. So the testing process, first up, I set up the target. It's just a box filled with styrofoam. It is placed freestanding so it can move on just a stand at about eye level. The actual experiment consisted of covering the target with a certain type of fabric, be it cotton, felt, or linen, and I used essentially increments of 3 layers. So I'd lay on 3 layers of a fabric, shoot at it 5 times, record the aero penetration of each impact, and then I'd add on 3 more layers of that same fabric, and then I'd do that up until I got up to about 12 layers, and then I'd take off all the fabric and start a new type. I did that until I got up to 12 layers for all 3 types of fabric. So the purpose of this project, it's meant to be a simulation of what's called the gambeson. And gambeson was a medieval form of armor. It's it's cloth armor. It's made out of many layers of fabric that have been quilted together, and records show that it was actually apparently able to prevent arrows from killing you. Yeah, they could stop arrows, is what I'm trying to say. The final conclusions of this project will be used to decide which fabric type makes the best armor for the least layer count. Now here's one way of displaying my final data. This is just a graph of the mean penetration of arrows at each layer count for each type of fabric. 67 total data points were collected, but in order to be able to actually test between the fabric types, analysis was only done on impacts of 6 layers of each type. So I only tested at each fabric being in 6 layers deep. Here's some quick charts, 6 of just all of the data I collected. Here's some box and whisker plots displaying the statistics for the 6-layer data of each fabric type. Now, my testing, I used 3 total 2-sample t-tests. One compared cotton and linen, another compared cotton and felt, and another one compared felt in the control group, which the control group was just the target uncovered by anything. And all of these were done with the fabric at 6 layers, barring the control, because for reasons I feel should be obvious. Here's my first 2 tests, and yes, they were as difficult to make as they look. And here's my final test. Now, the interpretations of these tests, that cotton has significantly less penetration than linen, but there's no significant difference between cotton and felt penetration. Felt also has significantly less penetration than the control. Now, what this means is that cotton is more protective than linen. Cotton and felt are of about the same protection, but felt has much more protection than a bare target, which, shouldn't really be that surprising. I had 3 main confounding variables, which were the actual thickness of the fabric. For example, the felt was, the same thickness, as about 4 or 6 layers of linen. Another variable was, where the target was actually hit by the arrow, because the target was able to move. If the target was hit at the top, more of the arrow's energy would be converted into movement rather than actual penetration. And if the target was hit at the bottom, it would convert more of that energy into penetration, which could have skewed the results. Another variable is how much damage I've already taken due to my error in not buying enough fabric. I actually had to reuse the same fabric from previous experiments, or rather previous iterations of this experiment. Now, what that means is that, say I was doing a test at the 3-layer level, put on 3 layers of, say, cotton, and I shoot at it 5 times. Then that same cotton, for the 6-layer test, I keep on those 3 layers that I already shot at, and just laid on 3 more layers. And so that was to conserve fabric. What I ended up doing is, the fabric at the very essentially bottom of the pile would get more and more damaged as it, had arrows shot through it, and that could have weakened it and made the tests at higher layer counts rather, less meaningful, less accurate, I should say. In the future, I'd fix these in 3 separate ways. I would set up the experiment to go by fabric thickness rather than layer count, just to remove that as a variable. I'd use a static target, I'd make it so it couldn't move to remove target movement as a variable, and I would replace the fabric between every test, use fresh fabric every time to remove fabric damage as a variable. So my final remarks: the study was decently informative. It was done, it was all right, but it could have been improved in so many ways. While there was no significant difference between penetration of felt and cotton, my monkey brain tells me that I want armor made of felt, just because the numbers were as a whole just a little lower and the graph looks like it's got a little less penetration. However, that's really just an irrational observation. There's no basis in statistics, and it's entirely possible that in the future, with more testing under different conditions, felt and cotton would turn out to be roughly evenly matched, in which case I would probably choose cotton over felt as an armor because it's much easier to sew. Another way this study could be, less improved, made more interesting, is use obviously different types of fabric. Could be a good way to collect more data. Use different types or draw strengths of bows at different distances. But to me, something that would be the most interesting is changing the arrowhead type. I just shot at these targets with broadhead arrows because that's all that I had. But it could be interesting to, like I said earlier, test with different arrows. If you could use, say, a bodkin arrow, an armor-piercing arrow, that could probably give you some pretty interesting results. So that's my stat project. Thank you so much for watching.